Hello everyone, welcome back to part 2 series of the YouTube series on pressure. Okay, so in this section, we will be covering how is pressure transmitted through an enclosed liquid, and these are the learning outcomes. You should be able to describe and explain the transmission of pressure in hydraulic system with particular reference to the hydraulic press. Okay, so have you ever seen an excavator scooping out dirt or sand and unloading it onto a truck? How is the excavator able to exert such a great force into the ground to scoop up the heavy dirt? Okay, the reason is because the excavator makes use of a hydraulic system. So in this part, we will be zooming into how does hydraulic system works. Okay, so this is a very simple, simplified diagram of a hydraulic system. So over here, you will see that there is a small force is applied onto a small piston, and this will create a pressure. This pressure will push the hydraulic liquid down. The hydraulic liquid is in orange. It will go down, and the hydraulic liquid will be pushed up over here onto this large piston, and the object that requires a larger force or a larger load will be placed on the bigger piston. So how does it work is, okay, it works by the principles that pressure will be transmitted equally in all directions throughout an enclosed liquid. Okay, so what do I mean by that? Let's zoom into it part by part. Okay, so in part 1, you have a force that is exerted on this piston 1. Okay, so this force exerted over this area of the piston will create pressure P1. So we say that P1 is equals to force 1, F1 over this area A1. Okay, then because liquid is incompressible, all the liquid that is pushed down over here, okay, will be transmitted to the other end. And we also say that the pressure will be transmitted equally in all directions at all parts throughout an enclosed liquid. So the pressure at here, P1, will be the same as here, at here, at here, at here, at here. All the pressure will be the same. Okay. Next, because of this pressure of the liquid that is acting up on this piston 2, okay, you have this pressure is equals to force over area as well. Okay, so we have P1 is equals to F2 over this area A2. Okay, so in short, we are just trying to say the pressure on both sides is the same. So F1 over A1 equals to F2 over A2. Okay, and so we can find the force F2 over here by using F1 times A2 over A1. So this is basically the working principle of a hydraulic system. Okay, but because these two pistons have very different areas, the area of A2 is much larger than the area of A1, the force F2 will also be much larger than F1, okay, based on this formula. Okay, F2 is A2 over A1. Because A2 is much bigger than A1, so F2 will be much bigger than F1. Okay, it's actually a multiplier effect. Okay, because force 2 will be a multiply of F1 depending on the area. Okay, if the area is doubled, the force will also be doubled. If the area is 5 times more, okay, the force F2 will also be 5 times more. Okay, okay, so it works on, recap a little bit, it works on two principles. Liquids are incompressible, and when pressure is applied to an enclosed liquid, it will be transmitted equally to all parts of the liquid. Okay, so hydraulic system usually works with oil, okay, because oil is a good lubricant, it's a liquid and it's a good lubricant as well. It doesn't work well with air because with air, as you push it down, the air gets compressed, so the pressure won't be transmitted equally to the other side of the piston. Okay, so recap again. Small force is applied to a small piston. This creates a pressure. This pressure will be transmitted equally to all parts. The same pressure will act on the larger piston. So this results in a larger force because F2 equals to the same pressure times area 2. Okay. And okay, so some of the other applications other than the excavator, we use it in our hydraulic car lift jack as well as in the car braking system. So you see in a car braking system, you just step gently on the brakes, okay, it will be able to exert a large enough force to stop the car wheels. Okay, the brake pedals here will have a large force to stop the moving wheels to brake your car. Okay, and then for your hydraulic car lift, okay, you just exert a small amount of force on the handle, and then this will be able to lift up your entire load of your car. Okay. Okay, so let's look into some work example. You have a hydraulic press and it has two pistons. The smaller one has an area of 2 meters square. The larger one has an area of 10 meters squares. A load of 1,000 Newton. Okay, in this case, 10,000 Newton. In this case, it's a motor car is being placed on the larger piston. What is the minimum force that must be exerted on the smaller piston in order to lift this load? And what is the distance that the smaller piston has to move such that the load will be raised by 1 meter? Okay, so the answer is I'm going to use the pressure. When I want to calculate the force acting on both pistons, I always use the pressure formula. Pressure equals to force over area. So F1 over A1 equals to F2 over A2. Okay, so I have information for over here because I have F2. F2 is 10,000 over the area, bigger area 10. Okay, so that will be the pressure, 10,000 over 10. I get 1,000 Pascal. So this 1,000 Pascal will be transmitted equally and it will also be the pressure acting on the smaller piston. So I want to find the force on the smaller piston. Force equals to pressure times area. It will be 1,000 times 2 because the area of the smaller piston is 2. I'll get 2,000 Newton. So with 2,000 Newton, I can actually lift up a car of 10,000 Newton. Okay, next one. Okay, I want to find the distance moved. Okay, so this load is raised by 1 meter. Okay, whenever I'm trying to find the distance being moved, I need to use the conservation of energy, which says that how much work is being done on this small piston must be equals to how much work that is being done on the big piston, because work done is same as energy, is joules. Energy cannot be created or destroyed. So if I were to have 5 joules of work done here, or 5 joules of energy applied here, okay, I should also have 5 joules of energy over here by this movement of this piston. So I'm going to use the formula for work done, which is force times distance. Okay, so force times distance on the large piston will be equals to the force times distance on the small piston. Okay, so the force on the large piston will be 10,000 times a distance of 1 meter equals to the force on the small piston, which is 2,000 times the distance. And you will realize that the distance moved by the small piston is much larger. Because I have a smaller force, I need to have a larger distance moved in order to create the same work done as the bigger piston, which has a larger force and a smaller distance. Okay. Okay. I have an extension for this part, so you will just watch the extension.